Hello and welcome to another tutorial. So this time around we are going to be making an in-game camera, as in an actual sort of object that is a camera that we can hold, that we can then point around and we can take photos, things like that. So that's what we're going to be getting up and running for today. So I already have a bit of a setup for this, and it's a pretty basic setup. If we take a look at what we've already got here, so we have this camera object. This is something I've built, so it's a little bit basic in how it looks, made using Pro Builder, but it does the trick. So we've got the body of the camera and the lens. So it has the actual camera here, and so what this is doing is this is capturing to a render texture. So something to be mindful of with this approach is this is going to be a little bit more expensive in that we are rendering the scene multiple times with this. So because we've got a second camera there, we are rendering it an additional time. There is an additional cost to that. So this setup here, we wouldn't have this where it's always running and active, because that could potentially be really quite expensive. We've got a few bits of UI there that we don't need or get rid of. So also what I've set up on the camera there is we have a main display and a viewfinder. Now, the way that I've done these at the moment is these have just been set up as a separate material, and we can actually take a look and see the materials here. So these are using a viewfinder material and a screen material. So I am actually going to change this a bunch because I want to have this be using some UI there for this. So using it, having it set up for it mapping onto a section of an object is not a bad approach, but the reason that's not really going to cut it for me is I need to be able to be overlaying a lot of stuff on top of that. I need to be able to moving and animating it, things like that. So the setup at the moment is just a super basic one where it's no code, it's just feeding into this render texture. That render texture, I've set the resolution there. You could be using different resolutions, different aspect ratios there for it. But that's what's currently set up for it. So the first thing is going to be getting the world space UI going for this so that we can change these away from using this material. So what I'm going to do is, and we'll place this on the body of the camera. So I'm going to create a world space UI here. So we set up a new canvas. We change it over to being world space, just to make it easier to work out where things are and position them. I'm going to just throw a panel in, which I'm just going to make that panel fairly dark and get rid of the background image. This will just help me with being able to sort of size and position it. Now, when you're working with World Space UI, I'm going to actually use two canvases, one for the main screen and one for the viewfinder. The reason being they're going to be different sizes, scales, and they're quite disconnected. So it's going to be a lot easier for positioning and adjusting them if I do that. So this is going to be the main screen. Now, when you're working with UI and World Space UI, what I recommend is set the width and height to something that's a logical value in terms of pixels. So in this case, I'm going to set it to 1920 by 1080. And then what I do is I adjust the scales. That's how I go about adjusting the sizing, the positioning of things. What I'm actually going to do is I'm just temporarily going to move this so it's not directly under it, so I can rescale this a little bit better, because that's something where it is under something that's already got a bit of a scale on it. So what I'm going to do is actually change these around. So UI, a empty parent. This will be the mesh. I'm going to change the camera ones here so that that scale is uniform. And then the mesh can have the 0.15. So it'll bring it back to the same size, but now what it means is the UI can be set up under here, and I'm not going to need to mess around with sort of silly scales for it. Okay, so that looks about right alignment-wise, so now I can get the scaling of this correct. So scaling-wise, let's go for 0.01 to start. So that's still pretty large. So we can drop that a bit further. That's getting pretty close. And then at this point, I might start to drop the number of pixels. So this might be a case where then, okay, well, maybe I drop this by like 4 in each dimension, because we want to sort of strike a balance with both scale and with the sizings there for it. That, probably if we drop that again, dropping it by 4 is pretty close, so we're nearly there now. So we can start repositioning this, and this is definitely a point where what I would be doing is adjusting the width and height, because we can see a little bit more height. It's going to get us pretty much where we need it to be. And then we drop the width. And this is where being able to do maths in the inspector there really comes in handy. Fine a little bit, so we can bring that over. So it might be able to just go up another tiny little bit. So now we have our UI there, so that's good. So what I'm going to do is we can add into this a raw image. So live display, and that we'll put this under the panel here. And what I can do is just make that fill the entire area. Get rid of that padding. And then I can select the render texture from the camera. So that's good. We've got that being brought in there now. What that means is for the body of the camera, I can actually come in here to Pro Builder and reset that to be using just the body texture. So that's the live display. Then I'm going to set up the viewfinder. Now the viewfinder, it's going to be positioned obviously further up. So we bring this up here. And the aspect ratio is going to be a little bit different potentially, but we can likely get away with just adjusting the scale. Will get us probably most of the way there. So it didn't perfectly match the viewfinder height, unfortunately. So that is about centered there. We drop the height a bunch. That's pretty good. So there we go. We've got our displays switched over to being actual UI. What would be nice though now is now we want to actually be able to take photos. And we want to be able to see things like, well, okay, how many shots do we have left? Stuff like that. Those will be useful things for us to be able to see. So we've got our live display. I also want to then have another raw image. and this will be last image. That goes from the viewfinder to here. And we just zero out all of these, so it's taking up the full space. So that's good. So these, we don't want that to have any scale on it. That should just be like that. So that'll be the last image. So that we will put behind there for now and have that turned off. I also don't want any of these to be raycast targets. Not that they should be able to be, but I'm going to remove the raycaster. Just because these, I don't need them doing any raycasting. I don't want anything interacting with them at all, so I'm just going to make sure that it's definitely not going to have anything interacting with it by just making sure those raycast targets are turned off on everything. It's just something I tend to be really pedantic about these days, mostly after having adding in reticles via UI and having that actually block raycasts, which is really tricky to track down. All right, so let's set up our script. So we're going to have our camera script. So this will be our in-game camera. So what we want to be able to do is tell it, take a photo, and then we want it to hold that on the last image for a little bit before then going back to the live display, or if we go to take an image again, for that to immediately go to the live display. So we're going to attach this onto our camera, and then let's load this up. So there's going to be a few different things that it needs access to. So it's going to, we're going to bring in Unity engine.ui. There's likely going to be a bunch of stuff we need with that. But one of the big things we're going to need is a bunch of just general sort of hookup stuff. So we're going to need the game objects for the live display image. And we'll actually call these the raw image. We use the actual raw image ones. Raw image, last taken image, and we want to have a control for show last image for, and we'll make that, maybe it shows it for like 2 seconds, we'll be able to adjust it. We'll also then need a last image hold time or show time remaining. So obviously we're going to drop that to below 0, so that's good. So first thing we want to have is we want to have a void take picture. So if we're taking a picture, well, one of the things we'll end up doing is last show time remaining is going to be show the image for a time. So I might as well update these first. So update the last image show time. So what I want to check is if that's greater than 0, then I drop it by time.delta time, and if that has gone below 0 or equal to 0, then what I do is the live display image .game object, so that we set that to true, so we show the live image, and we turn off the other one. So in this case, return to live display. Okay, so that's good. We've got that side set up. We need to actually capture the image though. So we're going to also need to be able to grab our render texture. So we'll have our render texture. And this will be the camera RT. So that will give us the render texture. So then we're going to also want to have serialized field, camera, and then the linked camera. Because generally with the render textures, we need to actually force it to be being captured at times. What we'll do is we will do a little bit of a test, see whether we need to. We'll see what sort of happens there. I'm also going to have here a texture 2D last image. So when I take this, what I want to do is that last taken image, its texture, I want to set that to last image. So update the last taken image display. But then what I also want to do is I need to shuffle stuff from that render texture into that last image. So that's a really important thing. I want to transfer that texture. So to populate that last image, there are different ways of doing it. I'm going to, an approach that should be able to work is under graphics. We have this thing, copy texture. So I should be able to tell it, copy from the camera RT to that last image. And then I'll swap which ones are shown after I have done this. Show the last image. Show the last image, and this will transfer the texture. So that should do the trick. With that, I likely need to make sure that last image is already initialized. But that's okay, because I've already got the render texture there. So I can be saying, well, last image is a new texture 2D. So I can ask the camera RT for its width. I can get the camera RT's height. Now I then also need the graphics format. So again, camera RT, graphics format. And with this, then in terms of other things, I can just be providing Unity Engine. I don't need bitmaps, anything like that, so I'm just going to provide none for the creation flags. And that should mean that I have that last image being populated. Now, copy texture is something that different platforms you may experience that it has different capabilities. Generally on desktop, you're going to be fine. Mobile generally seems to be okay these days, but it depends upon the, how new the device is and the capabilities of the device. This, for transferring from a render texture to a texture 2D, is not something that's 100% guaranteed to be supported. You may need to have a fallback option, which the fallback option is you can do a read pixels and then a write pixels, or a get and a set pixels is an option there as well. It's a little bit slower, but it is a way of actually doing that also. So let's link up some stuff for this. So we've got our live display image. We have our last taken image. We have our camera, and we have our camera render texture. Now we need to have it that it's able to kick off that firing. So this is something where we already have a little bit of support in the controller here for when we actually press like the primary button. So what I will do is link that up to the camera and link that to take picture. So what we're expecting and hoping to see is I can pan around, and then when I use the primary fire button, as happened then, it takes an image and it holds it for a bit. So take an image, Viewfinder still updates, but the main display doesn't. So we have it managing to capture an image, which is cool. We can do more than that though, because let's start to give this a limited number of shots, for example. So let's set this up where it has num shots available. And we might set that to, let's set it something really low. We'll say that we've got 8. And we'll just keep track here, num shots remaining, which I'll populate that in here. So num shots remaining is equal to num shots available. Down here, well, if num shots remaining is less than or equal to 0, we're going to do a return. We could also then do other things following that. Shots left. So we could be playing a particular sound, we could be displaying a message on the screen. There's different things we could be doing there with that. But num shots remaining, we'll update that. Let's set up so we've got a little bit of a display for that as well. So we can have a serialize field, text mesh pro, UGUI, shots remaining display. So in terms of this, shots remaining display, that text, pretty straightforward formatting. It's just going to be, we'll have it display it as num shots available. And then in here, this will be num shots available minus num shots remaining. That will just indicate how many we've taken. So then we can update that down here. So that will give us our display. We'll be able to see how many shots we've taken, how many we would have left. So I'm going to have that UI exist here. So we'll set up Text Mesh Pro, and this will be the shots remaining display. We'll get that linked up to the camera straight away so we don't forget it. And that shots remaining display, we want that to stand out a bit. So I'm going to actually set up a little bit of a panel. Controls. This panel, I'll position it down the bottom. And we'll just get this positioned nicely. Make that, say, 50, maybe 30, 40. This is the advantage of using decent sort of scale factors, and that makes it a lot easier for being able to adjust and position things. And that's the big reason why I really strongly recommend with the UI using a mix of the scale and just having a fairly normal size for it tends to work out a lot better. So we'll buffer that over there a little bit, center that. That's pretty good. Can actually probably just be left aligned like that. Width 100. Maybe 200 for that. Or 150. That looks about right. That should fit the display pretty nicely. So it'll give us a display of the number of shots remaining. So when we launch this, should be able to see, cool. So go and take a picture. go through, be taking each of the pictures, but now when I go to take one, nothing happens, which is what we expect because we've used up taking all of the pictures. So, okay, that's pretty cool. What if we then want to save those pictures? Because that would be really cool to be able to do as well. So we can do that. It's reasonably straightforward once we've got things there in this texture 2D to actually save these out. So, because that last image, if we take a look at the different things, we have encode to. And we can encode to a bunch of different formats. In this case, it depends upon what you're taking a photo of, would change sort of how you want to actually do this. But say I'm using an encode to JPEG, I could then provide quality level, things like that. So that gives me back a stream of bytes, and I need to write those bytes out. So that means I need a path to write them out to. So application.persistent data path is a safe location where you should have write access to, and that is something that will work on any platform, which is really cool. So we can use that for writing to any particular platform. So it's a really handy thing for doing that. So that's really great. We've got that. We need to make up a file name for it as well. So the file name, let's start it out with being pretty basic of shot, and then we can work out a particular number. It's a JPEG, so we can provide that extension. Now, I'll fill that in a moment. When we're adding the file name to that path, you might think, okay, well, I can grab the separator, I can do it manually. I really recommend it against that, simply because we've got system IO path combine, and it's going to do it reliably. It's going to do it in a way that is independent, that works regardless of platform, just makes life so much easier. So always, if you're combining paths, use something like this. It means you write the code once, it's going to reliably work on every platform. It handles whether there's a path separator at the end or not. It manages all of those weird little edge cases for us. It saves us a lot of time. It means that it works reliably. So I really recommend using something like it. So we can then encode it to a JPEG. So we're pretty close to being done then. So we can go system, IO, file, and write all bytes, file name, and then we give it this. So save the image to file. And what I will do is I will debug log for now, that file name. But let's improve this. So firstly, we want to indicate which shot number we've taken. So that's good. We've already got the ability for doing that. So we can put that there. Now that would mean that one would start at 0, which isn't great. So let's add a 1 in there. So, okay, good so far. But what if we are taking shots on multiple days, multiple times, things like that? Would be pretty handy to add in the date and time there as well. So what I'm going to also do is we can do a system date time now, and we can then do 2, and we could do like to we've got date strings, we've got date time strings, we've got a lot of different versions of different ones that we could be using there for it. FI with this, let's go to the short date string, and we're gonna move this up to here. Current time, just to make it a little bit neater. because then here we can do current time. Now, this, converting that to a short time string, could have interesting results in terms of it might generate a path that is not quite valid. We're going to find out. That is something where you potentially do want to mess with the formatting there and start to use custom format specifiers as an option. Let's take a photo, and we can see there that that is exactly what happened, that because we have these semicolons in there, and because it's adding in extra slashes, that's going to cause issues there. So what we have to actually do is we can do a current time dot to string, and if we use to string, then we can actually control the specifier there for this. So that we have a lot of options, and I'll show you, and I'll put a link in the description of where you can actually find all of these. So here we have a giant table of many, many, many different ones, and it gives you nice little examples for the different things. Really, really handy. So in our case, we want to indicate, the day. So that means we want DD. And again, this is something where obviously you want to think about formatting for in different regions. So we do DD. Then we might have, if we look at the different ones, we could chuck in the year and the month, which things like the month, we can sort of see there's, again, a lot of different versions for that. Month generally uses capitals, whereas the others use, like minutes use lowercase. So I'm going to actually do this as year, month, day. And it conveniently is also putting up a bunch of the formatting ones there. So we can say that, and we can say the hour, which that will have examples here. So we can have HH, MM, SS. So then if we run with that, that should give us something that's going to be able to be formatted for a file path. So it's saying you often will need to do custom format ones like that. And we can see I misread what the one needed to be for year. I'm going to guess it's lowercase. Cool. So we can put that in like that. Now, something that actually should be possible, because we're using toString, and we're using this type of one, this should work the same. This should actually still run that same formatter. And so let's run with this. It's a handy little thing when you're using that sort of style of strings, the interpolated strings. So go in, take a photo, and we can see it works. So you don't actually even need to do toString with it, which is really quite cool. I still often end up writing the toString just for force of habit, but really, really cool. So we can see that's where it's saying it's saving the pictures to. So if I open that up, which you can just copy that path. So if I copy that path, and it should be able to just run exactly that. And I can see I've got a few JPEGs here. If I take a look, those are blank. Even though if we take a look at where that's actually happening, that is happening after we've gone and updated this image. So it is happening after we've gone and saved stuff here. But this is something where copy texture does things only on the GPU. This goes to save things on the CPU. So that texture doesn't exist CPU side at the moment. So we actually have to do a little bit more stuff to make sure that we're able to be saving it out. Okay, so as we saw, the images that were being saved were white. And that is because, as we said, the copy texture is really cool, really fast. It is GPU side only. That's why it varies from platform to platform whether it's going to actually be able to work or not. So we need to be able to bring it CPU side. And that's going to be slower. That does have a higher cost to it. That's unfortunately just the nature of it, that it's going to have a higher cost there. So what we want to do is set this up so it's going to bring it over. So I'm actually going to copy that out, or comment that out, sorry. And what we're going to do is we're going to bring in using Unity engine.rendering. And the reason I'm doing this is because bringing a texture from GPU side to CPU side isn't quick. It's a slow operation. So that's why if you can get away with only using copy texture, so if all of this was just sitting in GPU, you'd be fine. But because this needs to come into CPU to be able to be saved to disk, we have to use the slower operation. So that's unfortunately the nature of it. But what we can do is we're going to set this up and tell the GPU that we need it to perform this reading, and we're going to do this asynchronously. So there is actually an async GPU readback. So we can tell it, I want you to request. We can tell it what we want it to request. So I want to request the camera render texture. So our camera render texture, we have no MIP levels for it. Then I can set up my async GPU readback request. This is going to then give me, I can set up a function here that it is going to run once that request has actually completed. What I would then do is I could say, well, last image, I can set its pixel data to, I can grab the action, say, hey, get data. I just want to retrieve that as bytes. And again, what I'm setting is just MIP level 0. And I tell it to apply. And then I'm going to move all of this into here. It does mean there'll be a little bit of a delay before it tries to take more. I could probably actually move this out of here. It's going to be fine to update that number of shots. And that avoids people, if they really spammed it, I doubt people could do it fast enough that it would cause an issue, but just in case. So that should do the trick. It'll run at async, it'll request that texture. Once it's got that texture, it's going to transfer it over to last image. This is happening CPU side now, so it means we should have that data available. So let's test this out. Firstly, make sure that everything still works as we would expect. So we can still take images. The behavior of the camera itself, no different. All of that looks exactly as it was before. Now it's going to take a look at the folder, and now our images have content. So if I get rid of all of those and we just only take some new ones, just to absolutely confirm, we want to make sure that we're not imagining things, that it's definitely working. Can get a dramatic in-flight one. And let's jump off the edge. And we'll get one as we fall to our doom. And we can check. And we've got our full set of images. So we have our camera working. It's able to be taking shots. We can save those out as an image. We're managing that in a way that is pretty quick, pretty efficient to be doing that, which is cool. Because we now have those textures CPU side as well, that would mean we could actually have then effectively a camera roll, because we could have a whole bunch of those textures now that we keep CPU side for then updating and displaying there, which is really handy. So I could actually set that up where what I'm going to do is I will have a list, texture 2D, captured images. And that will just be a list like that. And then what I will do is whenever I go to take an image, I will actually set up a new texture here for this. So we'll create a new one, do all of that transfer. And then the shots, what did I end up calling it? Completely forgot. Captured images. So we'll say captured images dot add last image. So we're just going to keep building up that list of particular ones, and that would mean that if we then wanted to have a little bit of a display of those, very, very easy to do. And what I'll actually initially do, so we can easily see that this is working, so we'll actually make that public. I wouldn't normally have that as something that is public, but in this case, it's going to be helpful for us to have that. So we can run this. Let's grab a few images. So we've grabbed our first one, second, and although the icons are quite small, we can see we do actually have those particular images here. And we can see each individual one there. So we do have all of those images in a list. They're all different. So if we then wanted to do further processing on those, if we wanted to have those as something that the user could flip through, we could very easily do that. That's something that would be quite straightforward to do. We could also set up something where, okay, maybe we want to be able to, we don't need that, we can delete the last taken image. So let's have a public void delete last picture. So this is only going to be valid if numshots remaining is equal to numshots available, then we actually just do a return, no images taken. Otherwise, what we do is numshots remaining gets updated. We can get rid of our last taken, or our captured images. So we can go captured images dot remove at, and we can use captured images count -1. So add or restore the available shot. Remove the captured image. And this we can actually tell our last taken image. So last taken image is going to be, we're going to be able to set its texture to null. And if we do have any cooldown time remaining on this, we're going to actually switch back to this. It's going to go to 0. And we'll force it back to the live display. Time to live display. And then the only final thing we need to do is update this. So that means if we don't like the last image that we took, we can just delete it. So we've restored the number of shots, everything like of that. We can connect that up, our player. Well, let's use the secondary fire. So secondary fire will talk to the camera and it will use delete last picture. So take a picture. It's like, well, I don't like that one. Delete it. Let's grab a bunch of ones. Yeah, didn't like that. And you can go back and I can just keep deleting ones, which is very cool. Taken a whole bunch of different ones there. Yeah, no, you just go through, delete the different ones that you don't like, and the camera, we can see that properly is updating. So we have our functional camera. We'll turn that into a prefab, so it's something we could easily attach on elsewhere. And that's something where we could go and modify exactly sort of, how many shots can be taken. We could have stuff where it's being moved up in front of us or not. You could have different post-processing just for that camera. So if I set up a post-process volume, that's in-game camera PPV. This, I definitely want to put this in a layer. I want to make it global. So I'm going to call this in-game camera is the layer. Layer in-game camera. We go to our actual camera here and we give it a post-process layer. Tell that to be looking for in-game camera. So that will mean any post-processing now we set up for this is just going to be applied to it. So we could add in a whole bunch of different ones. Say we wanted a bit of, we could do some color grading on it. So we could be changing the temperature. So you could easily have camera controls for changing color temperature, and it just works by adjusting the color temperature on the particular device here. Change the saturation, so we could desaturate things a little bit. Lots of different things that we could be setting up. We could be adding in a bit of motion blur, so that if we're moving around rapidly, as things are moving rapidly when we're taking photos, that gets captured in it. So that's going to mean we get some nicer effects. We could be turning on things like bloom. So we could add in a bit of bloom on that, ramp the intensity up a little bit if we wanted, or go really all out. Probably not that all out. That's actually looking pretty nice. Pretty happy with that. We could add in some different lens effects. So you've got lens distortion there. So if you wanted it that the lens you've got on the camera is actually doing distortions, then we could do that. Could be fisheye one. So lots of different things we could do. Do keep in mind, every post-processing one you add on there does make it more expensive. So that is something where, it does affect the cost of this. And we can actually sort of get a bit of a sense of that if we take a look and turn on the stats. So it may end up being something we're not going to see a huge impact for it. But at the moment, we have 59 batches. So it was doing 59 batches there with that. If I take this camera and turn it off, half the number almost. So we actually less than half. So we lose 30 batches for doing that. So it is going to have an overhead to it. It's not necessarily going to be an overhead that's a problem, and it depends on the circumstances, the setup that you're using it with, but it is something where there is going to be a little bit of overhead there for it. But we've got our camera. We can take photos. We can save those out as an image. We can delete those photos. We've got them in a list, so there's lots of things we could be doing there. We could be building up other camera controls. We have some post-processing there, so we could be changing camera settings like color temperature or different things like that. By manipulating the actual camera object itself, you could then go and change stuff in terms of the zoom and things like that, or the resolution. So the render texture itself changes and controls that resolution there. So I'm using 480 by 270, but I could equally go to 48 by 27, and you can see it becomes super pixelated. So the resolution that you set here matters. Stuff that you use here in terms of the format, things like if that matters. At the moment, I'm using one that's got red, green, and blue color components and transparency. If I went to only having red, then the image is obviously only red. I could change to ones where, different sort of settings that I could be using here. So it's something to be aware of, red and green. So lots of different things you could be doing there. Key thing is, we've got a functional in-game camera that we can be using now. Thanks folks, I hope you found the video helpful. If you're looking for the code for the project, I've included a link to that in the description below. That's available on GitHub there. You can use that freely for any of your own projects, commercial, non-commercial ones. You're able to be using it. If you've got any questions, chuck in a comment below. If you found the video helpful, chuck in a like and subscribe. Really helps out, really appreciate it. And if you're looking for other ways to support the channel, then I do have a Patreon, and the link to that's in the description below as well. But until next time, bye.